Now let us talk about the stack operation. The stack operation. So the stack space in MIPS, first of all, stack is word accessible space. Let's assume that's a software convention. Okay. Of course, we can deviate from that. We can say, okay, my stack is byte accessible, a double word I can push, and etc. etc. We'll see that. Okay, but let's for timing assume stack is word accessible space. That means we need to use only load word, store word kind of instruction in there. It starts from 7FFC to be aligned for word storage. Means if I want to push an data, a word, starting at this address, this address is byte, this place is a byte, right, from MIPS perspective. So this is storing a byte. Then for 4 bytes I'll go higher, like I'll store it in FC, FD, FV and FF, and there I reach the my user program accessible boundary by convention. Everything beyond that is used by kernel of operating system. So that's why it starts from this specific address. And you recall for the Mars, it's a little different. It starts from 7FFF for some plausible causes that I explained already in last lecture. Now, from data structure, like stack need a push and pop operation, right? You want to push into that memory and pop into the memory that there is always this kind of a stack top where we can push and new data comes out from the stack top, that pointer goes down and so on and so forth. MIPS does not provide a native push and pop operation. It is done by manipulating your stack pointer directly. So this is only place when you are messing up with the stack pointer, okay? But systematically. It is not randomly and arbitrarily you will be placing the value in the stack pointer. Systematically you will be manipulating the SP. So for this class, our assumption is that push operation should store the data into address pointed by SP, then decrease the stack pointer by 4. Okay, you will find other conventions in the net if you search, but this class follows this. Let's follow this throughout the semester. Push, first write data into the storage pointed by stack pointer, and then stack pointer decrease, it's pointing to a empty space to be used, right? So, and pop is just a reverse. It should first increase the stack pointer by 4 and then read the word data from that location. This assumption has been used for your programming assignment, for your project, and that project is, this is one of the very important assumption in the project as well. If you deviate from that assumption, your project may start giving issues. So please follow this convention. Push, first write data, then change stack pointer. Pop, first change stack pointer, it increased by 4, and then read the word data from that location. Okay. So yeah, this is the one again when you are looking back into the MIPS convention of using different segments, and stack grows down, stack starts from a higher address, and then as we push into the stack pointers come down and start pointing to the lower addresses. Heap, we are not going to talk about that, like a new malloc kind of thing. We're not talking about this in this whole semester, but it happens. It basically a part of operating system, how it can manage the memory, etc. So I hope you will get more insight into your operating system class for the heap usage. Now we want to copy this XP11 ASM212 and add some push and pop, like before the exit, like store word, like this. So we are using stack pointer as my base pointer, and relative to that I'm using a 0 offset. It's always like that. You use a 0 offset and store certain values, and then move down the stack pointer. So we are doing a add I of sp. It's kind of a sp equals sp minus 4. So we are kind of moving down by 4 byte, and then doing another store word pointed by the stack pointer. So these two together is a push. And the pop code is basically you are first changing the pointer, moving in the higher by 4 byte, and then accessing that word from that location. That your pop code is, right? So let's follow this convention in our throughout our semester. So store data first and then decrease stack pointer. Pop, first increase the stack pointer and then load the data.